Welcome to LabRats. My name is Ryan. Today we're going to be talking about this fun, mysterious force called magnetism. The magnetic force is one of nature's mysteries. From the earliest civilizations to modern science, humans have studied its abilities to attract or repel objects depending on their magnetic fields. The discovery of magnets traces back to ancient Greece, where they discovered lodestones, these rocks that will attract to each other. Ancient China around 200 BC was the first to use the magnetic lodestones. They used it as a compass. But it wasn't until about the 1600s that scientist William Gerbert described magnetism. He described the Earth as a giant magnet and discovered that lodestones were made of iron. Since then, our understanding of magnets and how we use them has grown immensely. We found out that iron, cobalt, and nickel are the only ferromagnetic metals. Today, we figured out how to create smaller and more powerful magnets. They have revolutionized our world. Every speaker that we use in our headphones, our phones, or the big ones at concerts, they all use magnets. The MRI is one gigantic magnet that's revolutionized medicine and saved millions of lives. Let's use our magnets today to discover more about this mysterious invisible force. For this lab, you will need magnetite or magnetic sand and some magnets. Pour the magnetite on a plate or a bowl and take your magnet and move it around underneath the bowl and observe how the magnetite will move with the magnetic field. As you move your magnet around, observe the shape of the magnetite. This is actually the structure of this invisible magnetic field. Magnets have two distinct sides. We call them the North and South Pole. It's important to note that opposites attract and actually the likes repel. For example, the North and South poles attract each other, while the like poles push apart. Now that we understand the shape of this mysterious invisible field, let's learn how we can make our own magnets. We call this inducing a magnet. For this lab, you will need a pair of scissors, a magnet, and a paper clip. We're going to turn this ordinary pair of scissors into a magnet. Pick one side of your magnet and rub it against the scissors in one direction 10 to 20 times. Then, just with your scissors, try to pick up the paper clip. If it doesn't pick up, rub it another 20 times. The more times you use the magnet on the scissors, the stronger it will become. Make sure you're always using the same side, or else you're just going to be reversing all the work you've done. As mentioned before, in ancient China, lodestones were used to navigate the ocean as a compass. We can actually use this idea of inducing a magnet to make a compass at home using simple materials. For this lab, you're going to need a bowl of water and a piece of styrofoam, a nail, and of course your magnet. Let's pour some water in the bowl and throw your piece of styrofoam on it. Now let's magnetize our nail. By using our magnet, rub your nail 20 to 40 times. Your nail will become magnetized. Place it on the styrofoam and back away. This nail, as floating, will rotate and actually align with Earth's magnetic field, pointing north, no matter where you are on this planet. Today, we were able to turn a pair of scissors and the nail into a magnet through the process called inducing, simply rubbing one side of the magnet in one direction again and again and again. This causes the iron atoms to align in this one direction, creating the magnet. In this compass lab, we turn the nail into a magnet and use the styrofoam to allow the nail to freely rotate to align with Earth's magnetic field. This creates a compass that will always point north. Now, if you are ever in a dire situation, you can always make your own compass and find your way back if you're lost. As always, happy sciencing!
Ferrofluid.